Welcome back, everybody, for Constant Velocity Continued, Part 2. I got Drew helping me out.
What's up?
And Callie behind the camera.
Hey.
So we're going to start by taking a look back at that graph and see what you guys noticed and told me from the previous lesson. So let's go take a look at that. From the previous video, many of you commented on the similarities that as you go left to right in the graph, the lines go up. They start at 0, and that they're straight lines. But as for differences, faster walkers have a steeper line and slower walkers end up with a more flat line, or a line that's not as steep. Now in this video we're going to check out some different situations involving that same track but walking in a different fashion. In our first situation, Drew is actually walking the track backwards. She started at 25 meters and is walking back to the start line at 0 meters. Now when you look at the data from Drew's walk in reverse, you'll notice that it's going to look a little bit different when we go to graph this. Her first point is not going to be 0, 0, 0 seconds and 0 meters. It's going to be 0 seconds and 25 meters because she is walking backwards. So as we plot these points on the graph, you'll see that this line slopes downward. It goes from 25 meters in 0 seconds down to 0 meters in 20 seconds. And so she's actually walking back towards that x-axis, if you want to think about it that way, in this graph. This differs from the previous graphs that we've created because in those cases we were starting at the start point and walking away from it. Here we're walking back towards the start point, so our graph slopes downward as we go to the right. In our next situation, Drew is walking to 10 meters, turning around and then walking back to the start line. When you look at her data, you'll notice that it goes 0 to 16 seconds, but her position changes from 0 to 5 to 10 and then back towards 0. So in plotting the first 3 points, you'll notice that this looks similar to the graphs where we were just walking the track as normal. We got up to 10 meters, and this line is going up as we go to the right, and it's a straight line. But as we go to graph the next 2 points, you'll notice that her position is now changing, not going up, but actually returning to the start line, 0. So her next 2 points are 5 meters at 12 seconds and then 0 at 16 seconds. This situation creates kind of a mountain peak situation where you notice the peak of the mountain is the farthest she made it away from the starting line, which is 10 meters. Then she returns back to the starting line. It may be difficult to tell, but in this situation, Drew is actually walking at 2 different paces. Once she hit 10 meters, she speeds up. Now, if we look at the data, you can see that she was traveling at about 4 seconds for every 5 meters up until 10 meters. After that point, she starts traveling at 3 seconds per 5 meters. Let's see what that looks like on a graph. So what you see here are the first 3 points graphed. 0, 0. 4 seconds at 5 meters, 8 seconds at 10 meters. But remember, at 10 meters is where she speeds up. So just as many of you said in the previous video that a faster walker would have a steeper line, when Drew speeds up, her line becomes steeper. And you can see what she would have been walking at is that dotted red line, and the green line represents her faster speed. Our next scenario has Drew walking at a constant speed, pausing at 10 meters, and then walking at that same speed until the finish line. Now to make sure that that pause makes it into our graph, you'll notice that in our data, it shows that she's at 10 meters at 8 seconds and at 10 meters at 11 seconds, showing that she didn't go anywhere. There was a pause there for 3 seconds. What you see graphed here are the first 3 points, her walk up to 10 meters at 8 seconds. But then notice how our line changes. When she reaches that 10 meters, she pauses for 3 seconds, and our line actually goes flat. There is no change in position for those 3 seconds. After that 3-second pause, you'll notice that her line continues at the same slope it was before, the same steepness it was before, until she gets to 25 meters at the finish line. This is a similar situation to the previous one, except that at 10 meters after Drew's pause, she runs to the finish line. When looking at Drew's data, you'll notice that the first 4 points are the same. 0 seconds, 0 meters, 4 seconds, 5 meters, all the way up through her flat line at 11 seconds and 10 meters. After that point, she runs at a pace of 2 seconds for every 5 meters to finish off the track. So up through 11 seconds is graphed. You'll notice that there's a part where she's walking to 10 meters and that 3-second pause where there's no motion. Now after that 3-second pause, instead of creating a line that is at the same slope or the same pace that she was walking before, you can see her run line is steeper than the line that she was walking at prior to that. For the final situation, my dog Ben wanted to get involved. Ready, Ben? Go! Don't eat grass. Yeah. Well, you can see Ben's data here. He didn't go anywhere. So graphing his data, seeing as how he never crossed the starting line, he doesn't ever have a position change. But time does go on. 12 seconds later, he's still at 0. And here's a closer look at his exciting data. Okay, so let's talk conclusions that you guys have about graphing constant velocity. A couple things you mentioned from the previous video was that a slower velocity is a flatter line, while a faster velocity is a more steep line. What we also saw in this video is that when there's no motion or a pause, that is represented with a flat line. We also saw that when graphing motion away from a starting point, the graph angles up as you go across the x-axis. And we saw the opposite of that. When movement was towards the starting point, the angle of the graph was actually down as you moved towards the right along the x-axis.
Hey guys, thanks for watching. Make sure you check Google Classroom for all your assignments.
And don't forget to hit that like button and subscribe, and check Ben out on Instagram. Peace.
Oops.
Hey everybody, thanks for watching the video. Don't forget to hit like and subscribe, and follow Ben on Instagram.
Check out Google Classroom for your assignments. That was bad.
Yeah.
That's not. Hey guys, thanks for watching. Make sure you check out Google Classroom for all your assignments.
Don't forget to hit the like button. Crap, start over. Car.
You're gonna have many failed attempts to this. 3, 2, 1.
Thanks for watching. Make sure you check Google Classroom for all your assignments.
Don't forget to smash that like button and subscribe, and check Ben out on Instagram. Peace.
Don't eat grass.